All right, good day and welcome to day 7. Today we continue our bootcamp, and for our outline today we'll be looking at just one thing, just like yesterday. So we'll be tackling 4 loops today. Whatever they are, we'll get to know, at the end of the lesson. And so let us get into code and look at what these 4 loops are. I have my file created in PyCharm as always. You can follow along with any editor of your choice. So let's just imagine that you have a list of tasks you want to be done one by one. And it can be as simple as, let's say, if you have names, which is a list of names. So we can say Alice, Bob, and Charlie. I'll take just that 3. And let's say I want to print out a greeting to Alice, Bob, and then Charlie. What I can do is I can just go one by one print, and then you know that I have to say names and then index 0. That is for Alice. And I can duplicate this line for Bob and then Charlie using their indexes. And it will work if I run it. You see that all their names are printed here: Alice, Bob, and then Charlie. So imagine for once that this list was 1,000 in length. So it has 1,000 elements inside. This will not be the most efficient way of writing the algorithm to greet all of them or to print out all those names. So that is where loops come in. We have a single piece of code. Think of it like a small bot or something like that, a small piece of logic that can iterate over each item in a sequence. So you give it just one logic, and then it uses that logic to iterate over each and every element in the sequence. The sequence being anything that is iterable, like a list or a tuple. Okay. So let's see how we will do such a thing in for loop. But the basic structure of a for loop is for, and then you can say for item in, say, sequence. And then you can do something for each item. Let me comment it out. So that is the basic syntax for a for loop. I'm sorry, give me a minute. That is the basic syntax for a for loop. This for here is the keyword that starts the loop. So the Python keyword is a special word in Python that starts the loop. And then the item here, which you can use anything to represent. I don't want to use the same rectangle. The item here, we call it the variable. So you can say the loop variable for now. It is a variable that changes for every item in the loop. And then this sequence here is the iterable that we are talking about. So anything that I iterate over, like a list, a tuple, or a string, or any other iterable object in Python. So in our case, the sequence is our names list here. Okay. This item, we can actually replace it with anything. It can literally be anything. Python wouldn't mind if we put anything here. Some people actually use I and all those things, but I really encourage you also at all times to make your code readable. So once this is a list of names, I can just say for name in. And in here, we replace our sequence with names. That means that let's see that let's just greet each user with a print statement, and then inside an F string, I would say hello, and I'll leave a comma, and then I'll bring name. What we are telling Python to do here is that already has a comment. It's Blair. Okay. So you cannot see my code at all. Please, I need confirmation before I continue. I want to know the Blair, is it that you cannot see it at all, or because I'm streaming at the regular quality that I use? Okay, I guess I'll continue. But if there's any other comments, I'll look at it and address it. Okay, so we are looping through, that is the term, we are looping through these names here. We are now telling Python that for name, in names, you should print hello name. What it will do is that for every instance where it goes over this name, or let me say for the first time, this name variable here will correspond to Alice on the first iteration. And then on the second iteration, the same name will correspond to Bob. And on the third iteration, that is after it gets to the end of the list, this one will correspond to Charlie. So this name that we have here, for every instance of the iteration, it will change to the next index. And that is why it's able to keep track of where it is and then print each of them out as we want it to do. So if I go ahead and then run this code, I see the same output as before. Of course, now we added the hello to make it like a greeting. But I see that it's greeting all the three that we have in our list here. If I go ahead and I add another person, initially when we're using the print statement, after I add one more person, I'll have to come and write a print statement for the person. But now all I have to do is to rerun my code. And because that name I added is part of the sequence or the iterable we are using for the loop, it will just also run when this loop runs. So that is the concept of the loops in Python, specifically the for loop. It just helps us to keep track or to repeat tasks without having to write logic for each and every one of them. So as long as we can put the objects of interest in a form of an iterable like a list or a tuple or even a string, then we can just write a simple logic and then run it over all of them. Okay, so we take a very common example, in fact, a simple one. Let me delete all of these and then come down and say, we will introduce ourselves to a new function today. So I can say for item in, and then the new function we want to introduce ourselves to is the range function. So for item in range, and then in here, if I zoom in onto it, like this and put my cursor on it. Let's wait for the documentation to pop up. It says create and return a new object. Okay, it is not really saying what I wanted it to say. Okay, then let me explain it myself. It's what the range function will do is that it will give you a list of numbers within the range that you specify. So if I tell it to start from 1, and then for the last index, it starts at, it ends at n plus minus 1. So if I want it to end at 5, I have to put 6 here. I can say print item. And then when I run it now, see that I have 1 up to 5 printed. So in case you just want to perform operations on a particular range of numbers from maybe 10 to 100, I can actually make it like 600 if I want to push my machine to the limit. So I don't really encourage you to be using large numbers for these things. Of course, 600 is not so much, so it cannot really push the machine to the limit, like I said. But if you put very large numbers here and your machine is not that powerful, it can worry you. So just with this particular piece or block of code, just this block, with just that block, we can just get numbers from 1 to 600 just with this block. The other way we could have gone around it was to declare a list that contains all the numbers ourselves. Yeah. So that is the easiest, the first example we look at, just printing out a list of numbers using the for loop and the range function. Okay, no comments. I assume that the stream is clear now. You can also check your network if you think it is blur. I think the platform will automatically adjust the stream quality to your network strength. So there should be some other 3 dots or settings icon there. Anything, an icon that is on the screen, 3 dot settings. If you're familiar with YouTube and those things, you get to know that when you click on some of those icons, something will pop up that defines the video's quality. So you can check if it is on a lower quality, you can bring it up to a higher quality. Usually starts from 144 to about 1080. That is the maximum I was able to get for the platform with the current subscription. Okay, so the next example, I think we have already iterated over a list of names, so this one actually is our second example. And then let us look at a little bit complex example or the use of the for loop. We want to write Python scripts that will get us the sum of all numbers in a particular list. So if I declare a list called numbers, and then let's just put in things that will not confuse. So maybe 10, 20, 20. So this one should give me 50 if I should sum them together. No, sorry. You don't put a comma after those ones. And so what I can do now is, I taught you another principle some time ago where I used the plus equal to operator. That was to say that if I say plus maybe numbers 0, because if I don't access the correct element, it will actually throw an error, plus equal to maybe 12. What this particular block will do is that it will take the old value of numbers 0, which in our case is 10, and then add 12 to it. Let me just reformat this thing. And then add 12 to it. So it will maintain 10, add 12 to it so that you get 22. Other than that, if we don't bring this plus and we just make it an equal to, it will replace what is already here. But if you want to keep it and accumulate it with another one, you just have to the plus in front of this. So if I want to get the sum of all of these numbers, I can declare a variable called count. Let me set the initial value to 0. And then I can now say for maybe number in numbers, I can now say that count, this our count, plus equal to number. And then at the end of it, or after the loop is done, I'll exit the loop. Now I've exited the loop at line 10. I'm no longer in the loop. The loop, all the code or the logic under the loop are indented. So if I had another line, let me just duplicate this one one more time. If I had other lines like this, these from 9 sorry, I'm trying to use two screen annotation software and they are not all allowing me. So from, let me just use this one. From line 9 up to line 13, you see that there's this space which I filled with my rectangle, green rectangle. That is to tell us that all this from 9 to 13 are inside the for loops block. So they are in the scope of the for loop. But for 14, you see that it doesn't start from here. It doesn't start from here like the others do. It starts from the very beginning. So that means I've broken out of the for loop. So I can now print the value of count which I declared up here. I only need one instance of this. And I can say, if I want to style it, so I can say the sum of all the numbers or maybe the sum is, because I look like making the sentence very long. And then I can put in here count. Check. Okay, no comments. So once again, if this code confuses you, it shouldn't confuse you at all. You have a list of numbers here, which the sum should be 50, 10, 20, 20. Count is 0. And then now for every number in our numbers, we can actually make it like item, but I just want my code to be readable. That is why I am using proper names so that you can really read it. I can actually make it for anything in numbers. I just want you to know that this variable, that you don't have to really be strict with that. You just have to make it descriptive, that's all. And then for each of the iteration, we are taking the previous value of count. In the first instance, when it runs, count will be 0. And then once this number starts, this loop starts, the first element will be 10. To take the old value of count, add 10 to it. So 0 plus 10 should be 10. And then because it is not done iterating over all the elements of the sequence, it will not come to this line. Which line is that? Line 10. In fact, we can check that one with another print statement here. Maybe let's see. Print, and then we can say iterating, that get it right, iterating over, and then we can put the particular number it is iterating over there. So over number. Let me try and zoom out a bit. So you will see that it will print all of this iterating over before it will come and print the sum. I told you that Python runs from top to bottom, but that doesn't mean that when it gets to line 10, it will automatically come to 11. No, it will not do that until it has exhausted all the elements in the sequence. Now let me run it. So at the second iteration, the value of count will be 10 because at first it was 0, we added 10. Now 10, and then you add 20 to it, so it will be 10 plus 20, which is 30. And that value will be stored in count because we are using the plus equal to. So the next time it will take 20, add it to the already 30, and then make it 50 for us. And I just want to put this line here at line 10 to show you that the code will not move to the next line until it has finished the loop. So let's see. When I run it now, you see that iterating over 10, iterating over 20, iterating over 30 before the sum was printed. So if I have more numbers in here, maybe let me add another 10, 20, sorry, 20, so that I'll get 100. It will print this for all the elements inside before it will come and print the sum, which should be 100 in this case. So you see that it's finished the loop before it moved to the next line. So that is how the loops also behave in Python. Okay. There are no questions about the loops. I think we are still good to go. Okay, so we take another example, which is a little bit complex than this one, but it still builds upon all the things that we have done so far. So I'll go ahead and then, no, I will not clear the numbers because I'll still need it. What we want to do now is to write a script that iterates over a list of numbers and gives us how many of them are even. So I can just go 1, 2. Let me just take this suggestion from Python 1 up to 10. And so how do we know whether a number is even? Well, I don't really know. Maybe there's a particular package or method you can carry on numbers that will tell you that it's even, but we will not be using those ones here. We will be thinking through the logic ourselves. Now, what are the properties of even numbers? Excuse me, somebody just opened my door. So what are the properties of even numbers, mathematical properties of even numbers? Well, we know that if you don't have a mathematical background, I'm sorry, but most of these things are related to numbers, that is why. An even number is perfectly divisible by 2. So that means that when we divide it by 2, it shouldn't give us any remainder. And if you remember when we were carrying out the operators session, I told you that there's this operator called a modulo operator used for performing modulus. And then what that one would do is to give you the remainder of a division. So if I put in, for instance, 10, if I print 10, and then the modulus, I told you that we use the percentage symbol to do that. 10 modulus 3, it should give me 1 because this 10, the first time it divides, it will divide it and then we'll be left with 7. The next time it goes in, it sees that the 3 can still divide the 7. We can have another 3 in 7. So it takes that 3 away to be left with 4. The next time it goes, it will realize that no, there's 4. 3 can also go into 4 again. So it will take the 3 from that 4. Then we'll be left with 1. So the next time it will come to find out that no, that 1, we cannot get 3 inside 1. So it will return that particular value. So now if I run it, I should get 1 at my terminal like that. Okay. So we'll be using the modulus operator. So if that particular number is not perfectly divisible by 2, then that number is not an even number. But if it is perfectly divisible by 2, then it becomes an even number. So I will also declare an empty list to store our even numbers. I'm not using odd numbers. And now I can say for number in numbers. What I want to do is that Python is already even suggesting it. So if number mod 2 equal to 0, or I told you also that we use this double equal sign for the check. So what it means here is that when it performs the modulus operation, you see that when I printed the 10 mod 3, it gave me the remainder, which was 1. So that means that this one will also carry out the modulus operation and return the remainder. It can be 1, 2, 3, 4, 5, whatever the value is. That depends on what is coming in. So if, let's say, the value turns out to be 3, we want to check whether 3 equal to 0. And the only instance where the division or the result of the modulo will be equal to 0 is when the number is an even number, because we are dividing it by 2. So a number like 4 like this, if you divide, you can perfectly divide 4 by 2 times. So in that case, after it takes the first 2 from it, you'll be left with 2. It goes again and takes another 2, and then it's now left with 0, so it will return the 0. So if that number that is returned is also 0 like this, it will render to be something like this, if 0 equal to 0, which is very true. So that is how we are checking for our even numbers. I wanted to see if I can maintain the zoom level. So if that is the case, then remember how we add items to lists. So I can say even numbers dot append. This I'm not inserting it to the first index or anything like that. I just want to add it to the end of the list. So no, the count was to keep track. Let me try and go back until I get that code and see. The count was not to be used for comparison. In fact, this symbol here that you see, let me use the other two, and that I'll not be allowed to zoom in with the other two also. This count you see here, or let me say this thing that we can say the operator. Is the plus equal to? It is not for checking whether things are equal. What it does is that it keeps the value. So in this case where we are saying count plus equal to number, what will happen is that when it gets here, it will look for the current value of count, maintain it, and then add number to it. But in this case, our number is anything that is coming from our sequence, which is the numbers up there. So on the first iteration, this number will be equal to this 10. And so what will happen here on line 9 is that now that count is 0, on the first iteration when number is 10, it will maintain the old value of count, which is 0, and then add number to it. So it will be 0 plus 10. And then on the second iteration, when number equal to, this number will be equal to this 20. But count will be 10 because we maintain the old value and then added 10. So what will happen here at line 9 on the second iteration is that count will now be 10. This line will maintain line 9 will maintain the old value of count, which is 10, and then add a new value, which is 20 here, to make it 30. And then to maintain that 30, the next time to add a 20 to be 50, to maintain that 50, the next time to add it to be 60, and so on. So we use this plus equal to if we want to maintain the state of the variable, the old state or the current state, add a new thing to it without really replacing what is already there. Because if I don't bring the plus and I just make it count equal to number, at every instance, count will be equal to the current number, and then we cannot have our sum. So that is what we're using the count for. I just hope I've been able to explain it well. Okay.
So now it will be even numbers dot append number. That means that if you find out that the number is even, then append number. So append that particular number to the even numbers list. Then we can break out of all this code. Now, this becomes a nested kind of code or something like that. For loop with an if statement there. Yesterday we did a decision making, so you know what this line is doing. And so what is happening here is that this if block is nested inside the for and also has its own code nested inside it. So if there ought to be loops, we will say nested loops. If there ought to be if statement, we say nested if statements. We can nest them inside as long as that is how our logic should be. But I now want to get the even numbers after all these have finished running. And so I have to come outside of the loop because I know from the first example that Python will never exit this loop until it is done. So when it is done, then it will have all the numbers which are even stored inside the even numbers. And so I can go ahead and now say print even numbers. And that will give me all my even numbers in the list. So let's just try out our code and see. And it gives me 2, 4, 6, 8, and 10, which are the even numbers in the range of numbers from 1 up to 10. Okay. Okay, there are no comments. Okay, so let's say you wanted to check in this case if the number is odd. We can use this same logic, but is either we can change this place to 1, or the best way to change the equal to be not equal to. So in any case, it will only be even when the output is 0. But if it is not equal to 0, then it means the number is odd. So we can try this one out and see. And that gives us all the odd numbers within the range. Okay. Okay. So that will be for the for loop in Python. I just hope that you got the concept. It's not difficult at all. For our variable in our sequence, do this or do that. And so as I always do, I will leave like 2 minutes for questions if there are any that I have to answer on air. Other than that, we'll close chapter on today's session also. Okay, so I assume that there are no questions. Let me thank you for your time today. And I encourage you to keep on practicing. If you have to watch the stream again, you know where to find it on the channel. And make sure you keep on practicing because you saw that today we are actually building upon what you have learned before. By checking whether the number is even, we are using the idea we have from comparison operators and all that, and even using the decision making we tackled yesterday. So make sure you practice before you come for the next, because tomorrow's own will also build upon the knowledge of this one. And I'll see you tomorrow for the 8th. No, tomorrow, sorry, tomorrow is a Saturday, so there will be no session tomorrow. Forgive me, I forgot. And so the next session will be on Monday, but you will have your weekly assignments uploaded to the Google Classroom. Make sure you do it and submit it on time, because if you do submit it on time, it really helps you. The lateness too will come with its own penalty, and I'm not sure you want to get a penalty. So just do your best to submit it on time, and I'll see you on Monday for day 8. Goodbye.